Welcome to the lecture on low power static RAM architectures. And the very important thing is please maintain running notes while listening to my lecture, because this lecture has only the schematic diagrams. I would be explaining those schematic diagrams, and some of the points are intentionally missing because you have to maintain a running notes. So coming to the concepts, first, what is a MOS static RAM memory cell? Because every RAM or ROM consists of a memory cell which stores one bit of information. So that is the definition of RAM memory cell. And what it actually consists? It consists of two cross-coupled inverters. So this is a single inverter. If you add another inverter where output of first inverter is connected as an input to the second inverter, and again its output is fed back to the first inverter. So this becomes a memory cell which stores one bit of information, either logic 1 or logic 0. And these would be the transfer characteristics of a single inverter, as you know this. Input on x-axis, output on y-axis. When input is 0, the output would be the maximum, and as you go on increasing the input, the output drops to almost ideal practical 0. And when you overlap the two inverters characteristics, transfer characters, this would be the picture, right? So this would be the first inverter characteristic, and for the second inverter, this would be overlapping, right? So the output becomes the input for the second inverter. So when the input is 0, output is high, and when you increase the input, the output becomes 0. So this output becomes the input to the second inverter, right? And this is an actual input given to the first inverter. So just we are overlapping the two transfer characteristics. And how many states does each memory cell has? Each memory cell has 3 states. One is read state, second is write state, and the third is hold state. You please do remember these 3 states. Read state means we are taking the information from the memory cell or reading the information from the cell. Write state means we are placing some information, that is logic 0 or logic 1, into the cell. And the third state is hold state. Right? So 3 states. So coming to the next point, how many types of SRAM cells? So just now we have seen what actually SRAM cell consists. SRAM cell consists of 2 cross-coupled inverters. So there are 2 types of SRAM cells. One is 40 and the second is 60. So first we'll be seeing what is 40 SRAM cell. The concept is simple. 4T means 4 transistors would be used, or 4 MOSFETs would be used in this. So this would be, it has 2 cross-coupled inverter. What are those 2? If I assume this as one inverter, right, whose input is this one and the output is this one. So this output is given to another inverter, and again this output is given as an input. So if you assume this is one inverter, this is second inverter, and the output of this inverter is given as an input, similarly the output of this inverter will be given to this. So it is nothing but a cross-coupled inverter, just the alignment is different, that's it. And I think you know what is this. This is a pull-up resistor. These 2 are pull-up resistors. This is a simple inverter, right? Actual input is given to the gate of MOSFET, and pull-up is a resistor. And what about this T1 and T2? These are simple pass transistors. Pass transistors. That means if this is logic 1, the information from this node is passed to bit line. if this is on, the information is passed to bit bar. So another concept is the RAM cell will produce complemented outputs, because if this is 0 and if you give 0 to this, what is this output? This is off, so complete VCC is given at this node, right, with some voltage. So these two outputs are complement to each other, and how we are transmitting these bits to the actual lines using this pass transistors, that is T1 and T2. So that's why it is indicated that bit and bit bar. That means if it is 0, this would be 1, and if it is 1, this would be 0. So the complements, output would be complement to each other as the concept of a flip-flop. So instead of using a flip-flop, we will be using simple static or simple MOSFETs or a bistable element. So this particular cross-coupled inverters are also referred as a bistable elements because it has two stable states, that is logic 0 and logic 1. And the source terminals of these two MOSFETs is connected to ground. Right? So don't think this is a ground. Right? This has a significant role. This line has a significant role in accessing a memory or SRAM cell. So this line is nothing but a column line, and this line is nothing but a word line. These two terms are very, very important. Right? So column lines and word lines or row lines. So if I give logic 1 to this, logic 1 is connected here, same logic 1 is connected here. So these two MOSFETs would be on. On means you can access the information from the cell to the column lines, because this would be on state. This is nothing but read or write state. As I said, it has three states: read state, write state, and hold state. So when you can perform read and write operations if and only if T1 and T2 is on. How these two MOSFETs would be on? If you give logic 1 to this word line. Right? And if you give logic 0, what happens? These T1 and T2 would be off. That means the information in this bistable element is held, or it would be in hold state. Right? So if it is stored with 0, that would be hold for a particular time slot until you make this word line as logic 1. Right? So accessing the information from the cell is done by two lines, that is word line and bit lines. Right? So this is very, very important. And this would be the layout. So don't get confused with the black and darkened parts. Right? So the layout can be drawn in any fashion. So as you know how to draw the layout. And so what is a 4T cell? It has 4 transistors: T1, T2, T3 and T4. T1 and T2 are the pass transistors, and T3 and T4 are the driver transistors. Right? So, and 2 resistors at the pull-up side. So this is the concept of 4T SRAM cell. And what is the drawback of this 4T SRAM cell? Means a resistor. You know that to fabricate a resistor you require more space than a MOSFET, because MOSFET is very compact, you can fabricate in less area. And moreover, if you want to change the resistance from 1K to 1 mega, for example, you need to fabricate a resistor 1 mega ohm separately, and it would be taking more area when you increase the resistance size, right? So that is a major drawback of the resistor. So the resistor can be replaced with a MOSFET. which occupies very less area. And the advantage of using a MOSFET is, you know the concept, right? If you change the VGS and VDS, the resistance of MOSFET gets varied. So it also acts as a resistor, variable resistor. So without changing or without refabricating the MOSFET, you can change the resistance of a MOSFET by simply changing VGS and VDS. So this is an advantage of replacing a resistor with a MOSFETs. So which results a 60 SRAM cell. What is a 60 SRAM cell? Simple concept. Resistor is replaced with a PMOSFET. That's it. Everything remains the same. So now I can say this is a CMOS inverter. Previously it was NMOS inverter. Now it is a CMOS inverter. Right? So how many transistors does it have? 6 transistors. So that's why it is referred as a 60, which consists of 6 transistors. Resistors are replaced with a PMOSFET because resistor needs more fabrication area, and fabrication is complex, and if you want to change the resistance completely, you have to refabricate everything. And advantage of this PMOSFET is simply by changing VGS and VDS, you can change the resistance according to the requirement. So how do you change the resistance? You know the concept, that is changing the aspect ratio, that is W by L. So you need to design 60 SRAM cell by changing the aspect ratios of these 4 MOSFETs, so that it will consume very less power. Right? And advantage of CMOS is it has least static power dissipation, because if this is on, this would be off, and vice versa. So there doesn't exist, or there is less chance of existing path from supply voltage towards the ground. Right? And the operation point of view, everything is same. Everything is same. Only resistance is replaced with a PMOSFET. And the word line, this is a bit line, produces a complemented outputs, and when it would be in read or write state if this line is given logic 1, that is word line. And when it would be in hold state, when this line would be given with logic 0. And layout, you can draw the layout in any fashion. This is one of the possible combination of layout, which is on a double silicon pattern. Right? And how do we design that? And you can easily conclude what are the advantage of 60 SRAM cells when compared to the 40. Advantage is less power dissipation, easy to fabricate, and fabricated in less area because there are no resistors. These are some of the advantages, right? And you can design a 60 SRAM cell by changing the aspect ratios, that is W by L values of the actual MOSFETs and MOS transistors. So this is what the concept of 40 and 60. So before going to the organization of the SRAM, once again I wanted to revise, right? So what actually the memory cell is, which stores 1 bit of information, which consists of 2 cross-coupled inverters. How many types? 2 types, 40 and 60. 40 means the resistors are placed in a pull-up, and how many states does each cell has? 3 states, read state, write state, and hold state. And the 60 means 6 transistors. When it would be in read or write state? When this word line is logic 1, it would be in read or write state. When it is logic 0, it would be in hold state. So before going to the organization of SRAM, this concludes what is RAM cell 60 and 40, advantages of 60. That's it. Thank you.